Okay, this is one of the data sets which is in the connector. We released it, I think it went live on GitHub about the very end of the week before this one just gone, but we started talking about it on Thursday. It's called Space Syntax Open Mapping. Here's the link, here's the page on GitHub. Essentially what it is a UK-wide processed spatial network model of Great Britain. I'm going to explain a little bit about the background of where it comes from, the kind of things that we have used it for and what it can show, as well as pull in a couple of examples about how it might be useful for some of these challenges as well. So it's essentially, it's data about the spatial network. So it's the network of streets between everything else. Space Syntax was a spin-out from UCL 25-ish years ago. And it was based on being able to consistently measure the characteristics of space across lots of different scales. Now, the reason for doing this is that we needed to understand how when you're changing a city or when you're designing a part of a city, to understand what that change is going to have, you need to have a scientific or a consistent way of describing space in order to be able to know what change you might be able to have or what change might come through. The way that developed was by taking the street network, turning it into a graph and analyzing that graph in a number of ways, and I'll explain that in a second. Typically, the data looks like this. So we pick up streets between things. Most of the time, we're working with planners and designers, and instead of giving them a data set, we really need to provide really visual, more kind of interactive data. So we use a lot of maps and diagrams, and they typically look like this. Through the research that has been done over that time, there's 4 to 5 consistent outcomes that you can associate with space. First one is pedestrian movement. There's lots of work looking at how the hierarchy of the spatial network affects the distribution of pedestrian movement. We know in some cities it affects distribution of vehicular movement as well. So if you know the hierarchy of space, you start to know where there are more likely to be more people. And most of the time, this is where most of the people are. It doesn't mean you can predict where individual people will be at any time, but it will give you a rough idea of where most people will be most of the time. If you know where people are, there's a whole series of other relationships that come from that. If you're going to open a shop, you need to have people walking past, otherwise you're not going to have customers and you go out of business. If you look at London, I think 80% of the shops are on the top 20% of the most connected streets. So if you know where is most connected, you know where the people are, you know where the shops are as well. We've also seen relationships to land values. If there's competition for particular locations in a city, that gets reflected in land value. Crime is another really interesting one. Again, certain types of crime, you don't want to be interrupted if you're climbing through somebody's window. So you're probably going to do that in a space which is less connected. You're less likely to have somebody walking past and interrupting you. If you're a pickpocket, you want to be in a place where you have lots of other people close by. Now, the last thing that we're getting into at the moment, which is really interesting, is how combination of street network and land use and public transport, how they all interact and how that can make people dependent on having a car or not. And that can have impact on longer term things like health and well-being. Now, the data set itself, it's from OS Meridian line data. I think there's about 1.5 million to 2 million nodes across the UK. It's already been cleaned. It doesn't include every single road in the UK, but it includes motorways, A roads, primary and secondary. Some of the kind of tertiary roads are missing. It also doesn't include every single pedestrian route, but it includes a huge amount. And we can still tell a lot about the structure of cities and the network of cities and how they relate to each other. So we took the data set. It's been cleaned and processed. We've published it in GeoJSON, shape, and CSV formats. We have every street segment has its own connectivity level, and to be able to combine it more easily with other data sets, everything has also been given LSOA IDs, MSOA, local authorities. I think there's one which is around workplace areas as well. So it should be able to combine with a number of other data sets quite easily. It doesn't include every single path or every single road. It still works quite well. So the way that affects it technically is that the smallest scale that we can analyze things is probably about 2 kilometers anything less than 2 kilometres, and then it becomes a little bit affected by the roads which are missing. But we think 2 kilometres is quite a good minimum scale. So the way it's analysed, we've turned it into a graph. That graph is then analysed using, I don't know if people know measures like closeness centrality, which in space syntax literature is always called integration, and betweenness centrality, which is called choice. So closeness basically takes every node. The thing that's important in space syntax is that the nodes become the street segments themselves, not the junctions. So it looks at every single street, and it says how many streets have I got within a certain radius, and how far away are all of those streets. And that's closeness centrality. Betweenness centrality, it looks at how useful every street is to connect everywhere to everywhere else. And it counts up the number of journeys that pass through. If you're linking everywhere to everywhere, the number of journeys that pass through every node based on taking the least ambient or going through the most direct route from everywhere to everywhere. So the kind of things that it's useful to pick out, this is actually showing Oxford. So if you're using, these are some of the columns which are included in the data set. If you're using integration at 2 kilometres, that will start to pick out where the centre of cities are and where there are local centres. So that can be a really useful one if you're looking at, we'll come on to this in a bit, but it feeds into things around kind of active transport. We can also see which parts of the city are more walkable because they have a more dense street network, smaller urban blocks, and lots of streets close to each other. That tends to make them more walkable. We can also see the opposite, which is which parts of the city are most isolated. So if we're looking at the most walkable, it tends to be red and orange, and that's the centres. The most isolated tend to be these kind of blues and greens, and this will feed into social isolation later. When we're looking at measures like choice, then we can start to look at things like which are the routes that people are more likely to walk along. So if you want to use this data set, the column to use is choice 2 kilometre rank. Now we've got ranks because if you're looking at individual cities, because we've got a whole UK-wide data set, the distribution is really wide. And if you look at London, London will always skew that distribution because it's so big compared to everything else, and all the values get skewed towards London. We've included rank because that allows you to see local hierarchies in quite a clear way. So that says, essentially, if I'm this street in Oxford at 2 kilometres, if I take every other street in 2 kilometres, which has got the highest level of choice. So that's the way that the rank is working. And this will tend to pick up the bits where you're more likely to expect to find people walking on the street. So these will be the routes that you'd expect people to be using. If you use a different scale, if you use 10 kilometres instead of 2 kilometres, that tends to pick out a wider scale of movement. It will pick up journeys by car, but it will also pick up other modes of transport as well. And we'll begin to pick up stuff like people cycling, public transport. And again, you can see we start to pick up a slightly different structure to the city. You can see the ring road around Oxford, but you can still see these kind of key routes that come into the centres. And if we go to 100 kilometres, all the data's there. It's just been filtered back the kind of lower order of the network. This will tend to pick out the kind of regional and national scale road network. So what you would expect on these roads would be that you're getting more fast traffic, HGVs, those kind of things. So there's a way, I think, where this can be really interesting to use for active transport in a minute. I think from a summary of the space syntax work is really that the physical elements of a city are really, really difficult to change. A street network, once it's there, it's basically there for at least 25 years, probably 100 years or more. Land use is really difficult to change. Density changes, but again, big changes in any of these things take a long time to happen. So once those systems are there, they're really difficult to change. They have a huge impact, not just on basically on what behavior is possible. So if you have two different areas with lots of people living, but they're cut in half by a motorway, it will make it almost impossible to get from one side to the other. So I think the really difficult kind of element is, or the difficult element when you're talking about changing the physical elements to people who can do those things, making the right physical conditions doesn't mean that you're going to guarantee the outcomes that you want, but it will at least make them possible. if you do it the wrong way, you make some kind of behaviour completely impossible. So things like you make it completely impossible to walk to work or to cycle, or you'll completely isolate big elements of the population. So in terms of the challenges, I think where the challenges could use this information is that if you're responding to these in a city, you have to be able to understand the physical conditions that exist in different parts of the city across different scales, and you can really use that to tailor very specific improvements or interventions to those areas. So just for the last couple, if we were looking at things like active travel plans, this was a really quick kind of run through to look at how it might be interesting to use this. You can start to take the example of Oxford to look at which parts of the city are more walkable. So you could use something like integration at 2 kilometres. I did have a slide in here that showed the census data from DataShine, which was a UCL visualization of the census showing commute to work mode. And you can see overlaps between the bits that we see as being more walkable in here, the red areas, and where people actually do walk to work. If you know where people are more likely to walk, you can then say, where are they going to walk? So if you took choice at 2 kilometres, you'd be able to then pick out those routes. You can then ask who else is using those routes at the same time. So you could begin to say, if we look at something like choice at 100 kilometres, are we going to get an overlap between people who want to cycle along these routes as well as HGVs and fast traffic at the same time? And then we can say, do those spaces actually have the infrastructure they need to support all of those different modes? So this is the visualization that's come out of the tool that Robin's been making. And that's, again, showing Oxford. So that would be one way of thinking about the constraints on the active travel. Social isolation, again, if we took something like integration at 2 kilometres, we can see these pockets which are more isolated, the kind of blues and greens. We could say, what are the demographic characteristics of these areas? And you could start to see, again, this is using DataShine. You can see this is showing health, and there are generally worse levels of health in some of these isolated areas, although there are pockets of poor health in other places as well. And then we can start to say, are there any overlapping risks between the risk of the physical infrastructure, so where you get an isolated part of the city created by the street network, how does that overlap with the demographic risk? And at the bottom, we have the Joe's Age UK model, which is in the connector. So we can see this isolated part of city here is also the same area where you have a population which has the demographic characteristics that are likely to be socially isolated elderly people. So there's a way of being able to profile and target very specific interventions using these data sets. So that's the data set. It covers the whole of the UK. I think we released it last week. In about the next couple, well, hopefully in the middle of next week, there will also be, I'll just show this. There's also going to be a website. And this is very draft at the moment, but there'll be something where you can look at the whole of the UK, and there's a whole series of measures that you can pull out. And that will be up at some point next week, and we'll be tweeting and talking about it. So that is the open mapping data set. Thank you.